Hi everyone, this is Sravani Sameera, Assistant Professor, Department of Chemical Engineer, PV Raju Institute of Technology. Course name Green Chemical Technology, and today's topic is Principles of Green Chemistry. So before going further about the principles of green chemistry, first we will learn what is green chemistry. It is a subject that deals with the design of a different chemical products and processes that reduce or eliminate the usage or generation of different hazardous substances. In our daily life, we usually use different chemical products. So this can be eliminated by designing a green products which doesn't cause any harm to the society and also to the environment. So here it applies across the life cycle of a chemical product. So if we consider any kind of a chemical product, so from the raw material selection till the disposal of that product, we will be considering the entire life cycle of a product. So including the design of a product and manufacturing and usage of that product, and also the ultimate disposal of that product is considered. It also eliminates the pollution at a molecular level, and it applies a different innovative and scientific technologies for the formation or for the innovation of a products. It applies a innovative scientific solutions for most of the real world environmental problems that are caused. It also reduces the negative impacts of different chemical products and processes on a human and also the environment. So first we will learn what is green chemistry before going further about the principles of green chemistry. So what do you mean by a green chemistry? So green chemistry is a subject that deals with the design of a different chemical products and a process which reduce or eliminate the usage of a hazardous substances. So we try to eliminate the generation of different hazardous substances. At the same time, we try to design a greener products which doesn't cause any harm to the society and also to the environment. It applies across the life cycle of a product. So if you consider a product life cycle, so from the raw material selection and process and manufacturing, usage and ultimate disposal are considered. So at every stage of a product formation and after its usage and ultimate disposal are considered. So in all stages, we try to apply a green chemistry, and it also prevents a pollution at a molecular level. It applies a innovative scientific solutions for most of the real world environmental problems. So most of the environmental problems can be solved by using the green chemistry principles. It also reduces the negative impacts of different chemical products on human health and also to the environment. How this green chemistry phrase has come? US Environmental Protection Agency coined the phrase green chemistry, so which denotes that to promote innovative chemical technologies that reduce or eliminate the use or generation of hazardous substances in the design, manufacture and the use of chemical substances or chemical products. So most of the chemical products are made. US Environmental Protection Agency coined the phrase green chemistry, so which denotes that it to promote most of the innovative scientific chemical technologies in order to reduce the wastage and also reduce the hazardous formation, hazardous substances formation, and also reducing and eliminating is the main motto of this green chemistry. So where we try to design and manufacture and use different chemical products. So all these products, they should not generate any kind of hazardous substances. So that is the main motto of the green chemistry. Environmental chemistry deals with the different pollutions that were caused and its effect on to the human health and also to the environment. Whereas green chemistry, it provides different solutions for your problems, and it also deals with the design of different chemical products. So hence, green chemistry and environmental chemistry are not the same. So in 1987, United Nations Commission on Environment and Development, they defined the sustainable development. So what is this sustainable development? So here we are trying to meet the needs of a present generation without compromising the needs of the future generations. So here, whatever be the needs that we have, they need to be met. at the same time, you should not compromise the needs of the future generations. So by involving all the green chemistry principles, we will be able to have such a kind of a environment where our needs are met along with the without compromising the needs of the future generations. So here what the sustainable development really means is like how best we can achieve, how best we can start to achieve the development at the same time having an environment and a social community in hand. So here if you see, we have a diagram about environment and economy and social community. So here if we have both economy and social community, we are lacking the environment. And if we have economy and environment, we are lacking a social community. And if we are having both the environment and social community, so we are lacking a economy. So here when we see this sustainable development, so it has all the economy, environment and social community, so all go hand in hand. So if we consider this economy, environment and social community, we will be in the wing of a sustainable development. So the natural step, an international movement that was started in Sweden, so they dedicated this movement to help the society in reducing its impact on environment. So they developed 4 different system conditions for this sustainability. So the first condition is about the materials from the earth's surface, earth's crust. So whatever be the surface, foremost surface of the earth, it's earth's crust. So materials, whatever be the materials that are available in this earth's crust, so such as like a heavy metals we have in the earth's crust, so those materials must not be systematically increased in nature. So whatever be the nature that is available to us with us, heavy metals which are taken from the earth's crust, they should not increase systematically. And the second system condition is persistent substances like DDT and CFCs. So all these substances are produced by our society. So these persistent substances, they should not increase systematically. They need to be reduced in the environment. The physical basis for the earth's productive natural cycles must not be deteriorated. So productive natural cycles means we have a water cycle in that. So these must not be deteriorated, and there must be an efficient and fair usage of resources with respect to the meeting the needs. So whatever be the needs that we have, they must be met by the resources, and these needs to be done very efficiently. So whatever be the water resources or the food resources or whatever be the energy resources that we have in our present world, they should be used very efficiently and at a fair manner. Unnecessary exploitation of resources is not recommended. So coming to the principles of green chemistry, we have 12 principles of green chemistry. So this was put forward by the American chemists Paul Anastas and John Warner in the year 1998. So this laid a foundation for the green chemistry. So now we will move on further about the principles of green chemistry. So our first principle of green chemistry is prevention. So prevention is the foremost thing that we need to apply in our daily life. So preventing the formation of a waste product rather than cleaning up the waste after it is being generated. So most of the waste is being generated. So preventing the formation of the waste product is always preferred when compared to the rather than cleaning up after the waste is being generated. So in our daily life, we generated so much of waste. So before that generating that kind of a waste, we should first think that whether this is really required or not. So if that kind of a thinking is implemented in our daily life, so most of the prevention can take place. So in this picture, if you see, so coffee to go in my own glass, using my own container and bringing my own water bottle, carrying my own bag or cloth bag. Okay, say no to plastic bags. And most of the cutlery we can eliminate from the restaurants, and upcycling your own clothes. So whatever be the clothes that are being manufactured, so they will be used for a 1 year or a 5 months or a 6 months or 2 months, and then they will be thrown. So this can be eliminated by using the upcycling your own clothes. So here we have to go for a zero waste, and there is no planet B. Our second principle is about a atom economy. So most of the synthetic methods, they are designed to maximize the incorporation of all the raw materials. So in a reaction, we have so many reactants which can be turned out into a product. So where in the final product, if you see, so some of the byproducts are also taking place or being generated. So these byproducts, they goes into a waste stream, and the products are the desired one. So if you have a reaction A plus B gives rise to C plus D. So in this, A and B are the reactants, and C and D are the in the product stream. So if you see here, so C is the only thing that is a desired one, and D is the waste product. So if you're having a waste product in your stream, so this goes into a waste stream. So you are incorporating all the molecules of A and B into a reaction, but some of the molecules, they are going into the waste stream, and some is forming into a desired one. So some of the reactants are going into a waste, so where your chemicals are being wasted. So here we have reactions with a high atom economy. High atom economy means most of the reactants are turning out into a product. So where they produce a very minimal waste and utilize the resources very effectively. So where this environmental impact can be reduced. So how we can have such a kind of atom efficient synthesis routes? So by using a catalyst in your reaction, or by using a multi-component reaction, we can enhance our atom economy, and where we can reduce the consumption of most of the raw materials, and also the energy can be saved. And the third principle is less hazardous chemical synthesis. So practically, like most of the chemical synthesis methods are designed to use and generate some substances with little or no toxicity to the people and also to the environment. So for most instance, like we use a catalysis as a reactions. So most of the catalytic reactions, instead of using a stoichiometric reactions, we can reduce a hazardous chemical synthesis. So by using a catalytic reactions instead of a stoichiometric reactions, we can enhance the rate of the reaction. At the same time, we can minimize the generation of hazardous substances in the synthesis. And also by using a renewable feedstocks like a biomass derived materials and bio-related materials, we can reduce the reliance on most of the fossil fuels. So where it reduces the carbon emissions also. Our third principle is less hazardous chemical synthesis. So for instance, most of the chemical methods, they are designed to use and generate substances which are little toxic or no toxic materials, usually for the people and also for the environment. So how we can generate such a kind of a no toxic or a little toxic substances or chemical products? So by using a catalytic reactions instead of a stoichiometric reactions, we can enhance the reaction rate, and we can save energy. At the same time, we can generate a less hazardous compounds in such a kind of a catalytic reactions. And also additionally, we can employ some renewable feedstocks like a biomass derived energy sources or derived materials. By employing all these kind of a bio-related materials in our process, we can reduce the energy consumption, whereby we can also reduce the carbon emissions also. So our fourth principle is about designing a safer chemicals. So most of the chemical products needs to be designed to affect their desired function while minimizing the toxicity. So by adhering to these green chemistry principles and prioritizing the substitution reactions, so with the less toxic alternatives. So most of the reactions, we use a hazardous substances. So in order to eliminate such a kind of a hazardous substances, we can incorporate a greener or less toxic reactants into that reactions. So whereby we can reduce the adverse impact of that chemical substances. Also emphasizing this biodegradability and also low energy input and end of the life considerations further enhances the sustainability. So here, reducing the energy usage and also using a biodegradable compounds, and also end of the life cycle, that means your life cycle assessment. So all these can be used to enhance the sustainability of that product. And fifth principle is using a safer solvents and auxiliaries. So most of the solvents we use needs to be a greener one, and which should not be toxic. So with a very less toxic or a no toxic solvents and auxiliaries needs to be used as a solvents, and also for the separation agents. So the usage of auxiliary substances needs to be minimized in order to have a safer environment. So design for energy efficiency. So energy requirements of a chemical process needs to be recognized, and they need to be energy requirements of a chemical process should be recognized for their environmental and economical impacts. And in economic impacts needs to be reduced, and at the same time environmental impacts also needs to be minimized. So if possible, synthetic methods need to be done at ambient temperature and pressure. So by doing it at ambient temperature and pressure, so further energy requirements can be reduced. And the seventh principle is a usage of a renewable feedstock. So most of the bio-related feedstocks can be implemented instead of depleting our own fossil fuels. So this is technically and economically very practicable, like while using renewable feedstocks like biomass, algae, forest residues, agriculture residue, all these can be incorporated in our renewable feedstocks. Our third principle is reducing a derivative. Unnecessary derivatization, like a usage of blocking groups or unnecessary and protection or a deprotection and temporary modifications in our chemical or physical process, these need to be reduced. So by doing a temporary modification in a chemical process or a physical process, it unnecessarily derives some other components which are not required, and which decreases the atom efficiency. So such a type of a process needs to be reduced and avoided if maximum possible. And our ninth principle is catalysis. So catalytic reagents, like as selective as possible, are very superior to the stoichiometric reactions. So most of the stoichiometric reagents can be replaced with the catalytic reagents, so that most of the reactions can take place at a faster rate. At the same time, energy consumption can be decreased. Our 10th principle is a design for a degradation. So most of the chemical products need to be designed and so that the end of their function, they break down into some innocuous degradation products, and they do not persist in the environment. So plastic bag is an example. So you are using a plastic bag, and after utilization of that plastic bag, when you think of the disposal, it takes hundreds and thousands of years to get it degraded. So instead, if you use a cloth bag, which can stay for a longer time, and at the same time, the degradation can be done easily. And 11th principle is a real-time analysis for a pollution prevention. So analytical methodologies need to be further developed to allow for a real time and in process monitoring, and also for the control prior the formation of hazardous substances. So if you see the present chemical industry, so most of the chemical industries, they have done their real time analysis. So before the formation of hazardous substances, they will be getting a proper information by the analytical methodologies, like process monitoring and controlling. Everything is done prior the formation of hazardous substances. And inherently, like safer chemistry for the accident prevention, that is the 12th principle and the last principle. So substances and the form of substances that are used in the chemical process, they should be chosen to minimize the potential of chemical accidents, including the releases of hazardous compounds, explosions and fires. So all these needs to be reduced by using a safer chemistry. So whatever be the substances or the forms of substances that are present in the reactions, they should not cause any kind of accidents or fires or explosions. So these needs to be reduced. So in today's class, we learnt about green chemistry, what is green chemistry and what is sustainable development, and the 12 principles of green chemistry. So once we'll look into the 12 principles of green chemistry. So prevention, atom economy, safer chemical synthesis, and safer chemicals design, and use of a safer solvents and auxiliaries, energy efficiency, use of a renewable feedstocks, reduction of a derivatives, catalysis, degradation products design, and real-time analysis for a pollution prevention. And the last one is accident prevention. By involving all the 12 principles of green chemistry in our life, we will be able to achieve a sustainable development without compromising the needs of the future generations. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.